Hey everyone, we're on to day 22 today. We'll see how today goes. I mean, it's a weekend day. It's very late on, so I expect the problem is probably not particularly easy. But we shall see. Oh, it's not a grid. I really expected it to be a grid. Okay. Calculate the result of multiplying the secret number by 64, then mix, then prune. Divide the secret number by 32, prune, multiply, mix, prune. Okay, cool. So what we can do, get rid of this grid stuff, don't need it after all. We can do yeah, we're in the 15 million range. Comfortably integers. But we might as well use longs just in case. So we do we first multiply by 64. And then we have prune and mix. Cool. To mix a value, I see. So we have an original secret number. Now I have to get the 2000th secret number generated. I see, okay. Okay, so we multiply by 64. Oh, wait. Okay, so prune is at least pretty simple to understand. Mix is still a bit tricky. So calculate the result of multiplying by 64, okay? And then mix this result into the secret number. Okay, wait. So it would be we do L equals mix L comma 64. So we do long other equals L times factor, and then return L XOR other. So we mix it, we prune it. We calculate the result of dividing the secret number by 32. Okay. Round the result down to the nearest integer. Okay. $2,048 is next. Then prune again. Okay. And then basically for each one, part 2 might just be increasing 2,000, but we'll see. We can do L equals 1 iteration L. And then we can do answer plus equals L. Nice. Okay, the secret numbers aren't just the price. The price the buyer offers are just the ones digit of each of the secret numbers. First time prices would be 306. Okay. This price is the number of bananas. He can ask another monkey to negotiate. That's quite unfortunate. So 30654. Four consecutive changes in price. Each buyer only wants to buy one hiding spot. You can only give a single sequence of 4 price changes to look for. Ah, interesting. Okay. So we need to actually keep track of basically all the price changes as well. I can do a map for that. Ooh, some of them might be the same number though. Maybe we do a list instead then. We can do a list of, yeah. Actually, we know it's 2,000, right? So we can do a list of long arrays. Does that make sense? I think it does. Changes equals new array list, and then for int I equals 0, we can start by doing changes.add new long. There'll only be 1,999 changes in the first 2,000, I think. So then we give a sequence of 4 numbers. Right. And I'll just never sell. Okay, cool. Ooh, so the thing is, right, if we do it naively, 4 numbers is, each number could be anything from -10 to +10. Oh, I guess -9 to +9. That's 18. 18 to the 4th is 100,000 different things to try. I guess that's not actually that crazy. Okay. Let's just do that then. It doesn't seem like too much. So basically I need so we start with, okay. Yeah, this is not too bad. So we start with this number, and then we do long future equals 1 iteration past. And then if j greater than 0, because the first iteration we don't want to do this, then we do changes that get I sub j minus 1 equals future a 10 minus past of a 10. Oh, we can't just save the difference, right? Because we also need to know what the actual number was. Is that true? No, I think we can just back out the number afterwards. Because we know the initial number, and then we can just sort of add until we get there. Okay, cool. So that should work for getting all the necessary changes. Then we do something quite weird. By weird, I mean not actually that weird, it's just brute force. I'm sure you've seen that plenty. I didn't really want to use A, but if I kept going, I would have used L, which is even worse because I already have an L defined elsewhere. So we're going to do that. And then basically we can do answer equals math.max, answer, comma, check sequence. Oh man, how do you spell sequence? There we go. IJKA changes. Okay, now we do private long check sequence. Oh, we can use ints actually because the changes are single digits, so they're guaranteed to be small. Actually, this should also just be a int array. Because when you take mod 10, it's guaranteed to be pretty small. Int array changes. So now we basically just go for each and find it for each one. So, I mean, we know we can start at the fourth one. Actually, let's start at 3. Yeah, basically go if change list b equals a, and change list b minus, let's go the other way, b minus 3 equals I, and b minus 2 equals j, b minus 1 equals k. This is really bad naming, but we'll see if it works. Okay, so if this is true, it'll sell at the very first time, right? It immediately sells, so it won't go again. Basically, we do result plus equals something. We'll say 2 for now, and then break. Oh, we do need the original numbers as well. Oof, okay, we can't do this enhanced for loop then. We'd have to do int c equals 0, c less than changes.size c plus plus, and then do int change list equals changes.get c. The reason is we also need long initial equals lines.get c mod 10. So that gets us the original, right? And then this is for int d. Goodness gracious, yeah, this is a lot of variables. Well, I'm in too deep now, unfortunately. Okay, so we start with result plus equals the initial number. Then we need to add each change. So result plus equals change list d, and then we go up to b, because it'll only sell after a sequence of 4, right? Yeah, so boom, 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 boom. Cool. Then we break upon being able to sell. Okay, so not the fastest. Which I guess makes sense, because we're checking over 2,000 over and over again. Yeah, I mean, it's not good when I have like 3 nested, it's like effectively 7 nested for loops. Okay, let's see if we ever even make it to the next number. Okay, this is rough. Well, I mean, it'll eventually finish. Let's start with these numbers then. So the answer is 19. Ugh, that's not good. changes lines. I should You know, I should just make a utility that literally just does what I'm doing now. Like, just given a list of integers, print them out separated by spaces. Okay, so apparently the best sequence is -2 +1 +1 +3. That does not seem to be the actual best. Huh. Okay. Maybe we can just put an extra at the beginning here. Check sequence minus, what was it? -2 +1 -1 +3. Okay. So it gives 3. Oh, that's not great. Why would it give 3? Am I off by 1 on this change list or something? Maybe I am? I don't think so though, because after these I'd be adding 5 numbers, and I think that's how many I'm adding. Maybe not though. I guess we can just do a system.out.println result. It's a lot of zeros. So many zeros. Okay. Guess that makes sense. Let's get rid of those lines. I just want to see it for this one. I get 0, then 2. Okay, that's already bad. Okay, let's do this. Let's also do arrays.toString changes.getC. See what we're working with. 0, 6. This is terrible. 0, 6 is already wrong. Oh, is it? Oh, they didn't give what the correct number is at. That's kind of unfortunate. Okay, I guess we just search for the sequence manually then. So it does exist in 1, 2, 3. Okay, so it exists in the 3 that you'd expect it to exist in. But it does seem like the original stuff, like the actual numbers, the price is 7. Like that part's interesting. So the second 6 occurs after -1, -1, 0, 2. Right, you should add everything up to that. I, J, K, A. Yeah, okay. So we can do, let's do this. before initial. Then after initial. Then after delta. It starts at 0, you add 1. Yep. Here you add 2, yep. And for the last one, you add 4. Okay, cool. So initial seems right. It's just delta is bad. Yeah, because it should be plus 6. And instead, right now, we're... Oh, is it this? No. It gives you 12. The answer is 23. That's very strange. Yeah, this is very confusing to me. So the initial 1, 2, 4. So the changes must... Okay, so the changes must add to 6, right? But this one, not even close. I mean, yeah, none of these are very close. Why are the deltas so weird? But we do want to add from 0. So 0, 6, 4, 4, for example. If that was a set of 4, then we'd start with 1, it'd go to 7, it'd stay at 7, which would be what this gives. Yeah, okay, we can check that, I guess. 0, 6, negative 4, 4. So we start at 0, we add 1, we then add 6. Yes, that works just fine. Huh, so why is this not working? Yeah, because we do break, which means we never try again. Does this mean our change list is wrong? I mean, we can try with 1, 2, 3. So 1, 2, 3. Oh shoot, yeah, the change list is off by 1, eh? It starts at 6. Why does it... The first 2,000... Oh, the first 2,000 changes. This should be 2,000. Right. This shouldn't exist. It should just be J. Okay, now we start in negative 3, 6. Okay, cool. Go back to you. Aha, now we're at 23. Cool. Okay, so let's undo this stuff. See if we get 23 doing this. Way too many print statements. Again, classic. Okay, we do get 23. Let's try this again, see if we get print statements. Okay. Now we undo this. And let's see what we get. Okay, so we're at negative 9, 0, negative 9, 9. We're about to hit negative 8. Yep. Negative 8, 5. Okay. So, I mean, it's slow, but it's not ridiculously slow. I mean, it sounds like we're going to hit negative 7. Yeah, okay, so we're about 20% of the way there. No, wait, 10% of the way there. Yeah, I'll just let it run. I mean, at the end, if it's wrong, it's a bit sad, but I don't think it's that crazy. Okay, let's have a general estimate of how big the number theoretically could get, right? So there's 2,000 different things. On average, what? 4 price changes, each of which is like a 1 in 10, 1 in 100,000. 4. Okay, it's actually really hard to predict how big the number could be. I mean, obviously the biggest is if you do 2,000 and every single one hits 10, so like 22,000 I guess is the limit. But that seems remarkably unlikely, and it's hard to compute how unlikely it is. Yeah, it's like very difficult to compute. Obviously we want a lot of positives, but we can't guarantee that even, like, oh, actually we can, I guess. Yeah, it's always positive. So I guess naively, each one could be around 5, and then the goal is just maximizing the amount you see. I don't know if it'd be randomly distributed, but like as I said, there's 19 things to the fourth. It's 130,000. Like naively, if you chose a random one over 2,000 times 2, like every given one only has a 1 in 65 chance. So it'd be like, what, like 30 something of these have it? 30 something times you're averaging 5, it'd be like 150. Yeah. So you're sort of pretty low. Around 150 maybe. But it does seem like it's going up. It's 2,000 something now. I wonder if there's certain sequences that make more sense. Obviously, the sequence existing is already sort of a big deal. But maybe certain sequences are better because they represent higher price points? I don't really know exactly how to think that one through. Yeah, also, I'm curious how you could do this with a decent runtime. Obviously, brute forcing is quite slow. I think anyone would expect that. Oh, hey, we're over halfway done. But it's not clear to me what's a faster way necessarily, because like, how can you do this without checking through each list of changes? Like, if it's slow because my change generation was slow, that's one thing. Like, maybe I can optimize that. But like, generating the changes was pretty fast, so I don't think that's the issue. It's how do you check for each subsequence of length 4 that I'm not very sure about. Maybe there's a way to go inverse, like start with the series of changes and then record sub-series of 4s from the change log. But I wouldn't know how to do that rigorously, because like any individual one might not have it, right? Like, even taking this shows that there's around 400 that do, which is pretty good. I mean, 400 out of 2,000 is way better than the expected, like 30 out of 2,000, right? But like, how do you know that it's going to be that high? I really don't have a strong sense of how you would check that. It's just such a large list, right? Like, you could record the first value for everything, but that's just as bad as looping through the entire list, because if you want to record each change list's possible like set of 4 sequence changes or like price changes, that ends up being pretty similar, I think. Okay, but we're getting there. We're at list 2 means we've done -9 through 2, which is quite a few. It's 12. Oh, it's done. Let's see if that's right. Nice. Okay, I mean, it's a bit slow. I do wonder how you can properly optimize that. But it's, we're back to having a reasonable day. I get to sleep at a reasonable time, which is great. See you guys tomorrow for day 23.